Hi, my name is Zack Scholl, and today I'm going to be talking about Gno, a interpreted language that is a lot like Go that you can use to write smart contracts. And the application today I'm going to talk about is generating ByteBeat music with smart contracts. This talk is taking place on October 12th, 2023, so if you watch this in the future, just know that some things I show you in the toolchain may have changed. So first of all, what is Gno, or Gno, however you want to say it? Gno is an interpreted version of the programming language Go. It's created by the Cosmos co-founder Jae Kwon about 2 or 3 years ago, and it's especially optimized for the blockchain. It has a system of execution that works on distributed systems. So all these different nodes can be running the same program with consensus, and they can all inspect the state of the program. But practically speaking, Gno is basically Go, but it's deterministic, so it doesn't have crypto-rand, web calls, imports from non-deterministic libraries. And under the hood, Gno code is transpiled into Go code, so it leverages a lot of the Go compiler system and Go tools. Basically, if you can write Go code, you can probably write Gno code. And if you can write Gno code, you can pretty much immediately start writing smart contracts and developing systems that are for the Web 3. So what are smart contracts? A smart contract is essentially a computer program that's stored on the blockchain. These programs are executed according to what is defined in the code when they're uploaded to the blockchain, and they cannot be changed once they're uploaded. The smart contracts can be used in many different ways. They're especially useful for automating transactions, but they're not strictly limited to decentralized finance. They can be used for any Web3 application that you can envision, like an incentivized social network, reworking basically how we can think about the web and how the web is incentivized. So smart contracts that are written in Gno will run in this Gno.land ecosystem. What is Gno.land? So Gno.land or Gno.land is a platform to write smart contracts in Gno. So Gno is the programming language, and Gno.land is basically the server that will host the smart contract. It's the first of a series of Gno Layer 1 chains, and it's built on Tendermint 2, Cosmos IBC, and it's secured by proof of contribution. The main priority is simplicity, so that's why the language core is centered around Go, a very common language now, but also security, scalability, and transparency, especially the last one. All the code that is uploaded to Gno.land on the blockchain is not obfuscated. It's actually available to see the source like any HTML page. So for example, we have a testnet running right now, test3.gnoland, and then /r for realm, and this is a demo board, a test board. So if we go to this URL, it's live right now, and you can see basically a test board. This is markdown file that's been rendered to HTML with different posts that you can go to. And this is a smart contract. It's a web interface to a smart contract. And we can see the actual code for the smart contract by just clicking this source button here. And these are all the code files. All the smart contracts that are on Gno.land have a special function called render. We can see that here in the render.gno. And I'll get more into this, but you can see already it's a lot like Go code. And here is this function, render, that's like a read-only state of the smart contract. And you can put whatever you want in here. And if you return markdown, the markdown is rendered into HTML and shown on the Gno.land website. So it's a really easy way to interact with your smart contract. And I'll talk about that more later. There's currently no main net. So we're going to get started today by running a local system, and we're going to build locally and dev locally. So it's very useful today for developing your development environment and getting ready to use Gno. And we're going to use Gno today to do something that maybe hasn't been done that much, and to actually generate audio on the blockchain. We're going to generate a specific kind of audio called ByteBeat, which is a minimal programming language for synthesized music. It's discovered around 2011 by VizNet in the demo scene as a way to make very short computer programs that generate complex music. So for example, this is a simple program. It's a C program, and it just takes an iterator T and then does operations on T over and over, a variety of operations, bit shifts, exponentials, adds, subtracts, logics, all this, and then it just outputs the number. So if you compile this GCC, run it, and then just take some of the output into a file, and then just say a sampling rate of 8,000, and then convert that file to a WAV file, you can get audio. So if we play this, this will be some of this audio. It's much more complex than you might think from just like these 3 lines of code. It's a bit of a curiosity and kind of like a chiptune or cell phone ringtone kind of thing, but for the purposes of today, it would be fun, I think, to put this kind of minimal programming language in ByteBeat onto a smart contract. So today we're going to use Gno, and we're going to develop our IDE and have a dev environment to writing Gno and then putting it on Gno.land locally to implement this ByteBeat music in the blockchain. And if you know Go, you pretty much already know Gno. So I'm not going to go over things about Go today. I'm just going to help you get started with the tooling, the ecosystem, and take some first steps into creating a realm or a smart contract to work on Gno.land. So let's first set up a computer to write and run Gno code on a local instance. So what you need is a Linux system or Mac OS. Gitpod is probably okay as well. You can just start a Gitpod Golang environment in Visual Studio. Visual Studio Code IDE is recommended. It's the best supported currently for the IDE, but this may change in the future. And also you need one of the almost latest versions of Golang. So open your IDE and install the Gno please and Go Fumpt. So these are the installations here. Go install, then you'll do this one. And then we install this extension. So I'll move over to VS Code. And I've already installed them, but you can install them and then go to the extensions and look for the Gno extension. And this also has instructions on how to install. So Go Fumpt and Gno please need to be installed, and then you can install this extension. And that will help a lot with linting and formatting as you're writing Gno code, because it's almost exactly the same as Go, but a little bit different, enough that it has its own formatters. Okay, so now we'll download and build Go. So we're going to use a forked version of Gno that I forked for this workshop that has some of the resources. Also, it removes some limits of the allocation and CPU usage so that we won't run into any errors when we're generating a lot of audio. So first we'll clone it. Okay, I just want to make sure I don't already have it. So we'll clone the workshop and then CD into it, and then we're going to change to this branch for the workshop, the ByteBeat workshop. Great. So we'll change to that branch, and we are good. So next thing to do is to run make build. And make build is going to install Gno. So we're going to run make build, and it's going to install Gno key. I already have it installed. And it's going to install Gno. I'll talk more about those. It'll also install Gno.land, which is going to run the main server for the distributed blockchain. And Gno web is going to be our interface with the blockchain. And it'll run that in the background when we're ready. So the Gno command is a lot like the Go command. You can write Gno help, and it has pretty similar, if you're familiar with Go, it has pretty similar commands. Mod, build, clean. And we'll talk more about it here. So first thing we're going to do is we're going to make a key. So making a key is the first step to using a blockchain because it needs to track tokens, and it's for the security. So first we're going to run Gno key, which is the tool for manipulating keys, and we're going to generate a BIP39 mnemonic right there. So now we'll write Gno key. Now we'll do Gno key add, and we'll make a new key. Gno key add, recover, and then my key. So I already have my key, so I'll do your key. And then enter a passphrase again, and then this BIP39 mnemonic. And I'll just paste that here. Okay, so now we're going to do no key list. You can see you'll have your keys. I have my key that I generated before, and another one called your key, and then other ones that I generated. So they're all listed here. So now we have a no key that's on the chain, not on the chain, but in our key ring. And now we need to add tokens to it. So we're spinning up our own test net, so we can directly add our key into the Genesis block. So if we open this file here, Gno.land/Genesis balances, we'll add a new line. I'll first go into the folder that we have, workshop. And then if I go into Gno.land, Genesis balances, we can add in our key. So we'll do Gno key list, and I'll add some of my keys here. So I have your key here. So this is the public address I'm copying. And I'm going to add in 10 million Gno. So this is your key, and then I'll add another key. I'll add my key. And you can add your key, whatever key you have, just so that whenever it starts up, you will have allocated Gno tokens that you can use for gas fees, so you don't have to worry about gas fees. And that's it for the tokens for the gas fees. So we're going to write a smart contract. And to do that, we'll write Gno packages and Gno realms. In Go, things are packages. So you write a package for like a table or a package for like a car. But in Gno, we're just distinguishing between a package and a realm. And both are like Go packages. But a Gno package is code specifically that doesn't have state. And you want to think of it as code that is probably going to be reused a lot. It can be code that imports realms. Realms can import packages, packages can import realms, but Gno packages don't have any state. A Gno realm is basically the actual smart contract. It's Gno code with state, storage, can manipulate tokens, and has this special render function that can be called by Gno.land for rendering on the web interface. And the important thing about realms is that any global variable in a realm persists. So it's kind of like a database. So that program, that realm, is constantly running, and when it's running, all the globals will have the value. So if you have a counter, you counter up 1, the next time that code is implemented, that realm is used, that counter will have been incremented that one time. This will make more sense as we go. Let's start with a smart contract by starting with the Gno package. And we're going to be writing a ByteBeat smart contract, so we're going to need some things related to music and audio and then ByteBeats. And this is going to be very simple, just to generate audio. In the future, it could be extended to like NFT, like music sharing or incentivized social network with music and code, where contributions are incentivized and streams are rewarded back. That can all be done, but for now, let's just write some simple Gno for making audio. So we're going to start at the very beginning on like an audio format. So Gno doesn't know what an audio format is, and we have to write our own. In Go, people have written these before, so I'm going to copy a lot from that, but you can get the basic idea here of what we need to do. We need to have a WAV file format, and a WAV file format is a subset of the RIF file format. And the riff file format is shown here. It's basically the sample data at the end. So you have all these samples. This is a 16-bit sample, so you have 2 bytes for a left channel, 2 bytes for the right channel, left, right, left, right, left, right, over and over. And in the beginning, you have some special chunk descriptor. So you have a thing that says riff and a thing that says wave in this format. And you have some specific chunks of various sizes. So some of them are 32-bit, some of them are 16-bit, and these will need to be specifically allocated. So we're going to write a package to do that. We're going to specifically write a package first to simply write riff files. So we're going to make it easier on ourselves to write a riff file, and we're going to just do an IO writer wrapper around some write chunk. So first, we're going to do this this will be a package. So we're going to edit the file or make a new file in examples/Gno.land/p. P is for package, and then /demo. The location isn't that important, but you can define it to be anything later on. But for now, it's easier to keep everything in the examples. So we'll go ahead and do that. Let's make a new file. So we'll go to examples, Gno.land/p, and then I made a folder audio, which we're going to work in, and I've already done some of the files, but we're going to make a new one here called riff.gno. And I'm going to start writing the code. This is Gno code, but it looks just like Go code. So it starts with package, and we're going to import, we're going to need encoding, binary. We're going to need IO, and then, let's see, we're going to have a writer wrap. So we have IO writer, and we'll have a new writer. So it's going to wrap a writer that's given to it. It's going to take a file type that will be written to the riff file, and a file size that will be written to the riff file, and it's going to return a new writer or an error. So far, just like Go code. So we have our new writer, wrapping that, and we'll write first, as we saw here, we need to first write riff to it. That's the start of any riff file. So we'll write the riff bytes. For some reason it's error, we can pop back. And now we need a way of writing a chunk size that is a 32-bit chunk size. So we're going to write some helper functions here. So we'll have, because we're going to have to do this multiple times, we'll have a write uint32 that can write a 32-bit number. And we're going to just make use of the binary package here. So we have 4 bytes, 32 bits, and we're going to do, it's in little endian. We're using the put uint32, so we're going to put that in there. There we go. So then we can easily write w2.write uint32, and we'll write that file size there. And then we're going to write the file size and then the file type here. So if should be wave, but this is agnostic to what it actually is. So whatever the file type is sent to us, we'll write in. Because riff is just a subset of wave. It doesn't necessarily have to be a wave. Oh, that's redundant. So there we go. So now we have a new writer. And then we'll have our chunk function. So this will write chunks, which will make it easier to write that header. So we have a chunk and we have chunk size. So here are these different chunks. So you can see we have a chunk here, They are 32 bits. So we will have the, oh, those are not the chunks. Yeah, we'll have a chunk name and then we'll write the data. So we have the ID and then the actual value for it. So first we'll write the ID. And if there's error, we can return. And then we'll write the 32-bit chunk size. Great. And you can see my formatter is actually formatting. So that's all working. And for posterity, because we'll actually need this later too, let's make a 16-bit version of this one. So we have 16-bit, 16-bit, 16-bit. Okay. So far, all I've done is written Go code. This looks just like Go if you've written Go before. Really nothing special about it for Gno, but we'll get to that. So let's test this, and the tests are actually also very similar to Gno. We have a test package underscore test, and then we can write Gno test, just like you write Go test. So I already made a little test package here, and you can see it's pretty much exactly what you'd expect for a test package from Go. It starts with tests, uses testing.t, and then it runs a little test, writes a wave file, writes a chunk, and generates some bytes and checks to make sure that they're correct. So we can run this here using Gno test and -- verbose, and then the path examples, Gno.land p demo audio riff. So we've done that and we pass our test. So all the code is working. If something wasn't working, like say we allocated 5 bytes here, let's see what would happen. We have a fail. So just like you would expect, it's just like Go code. You can write your tests and test the actual Gno packages. So this is Gno code. So when it's run, it's actually interpreted to Go and then compiled and run as Go code. So there we go. We have a little riff package. And now we also need a wave package. And I'm going to be basically porting this UPy Go wave. So I couldn't import this directly because it's not guaranteed to be non-deterministic as is. So I kind of ported what I needed for Gno today. And for this, I won't go through it bit by bit. I won't write it out, but I'll just show you as this one's already been written. So if we go to wave, there is this wave.gno. And wave.gno imports riff, and it has wave format, audio format, sample, writer, and we create a writer, and this has all the block align format, riff size, and then writes all the chunks out using the unit 32, unit 16, basically following that format here. Oops. Lost my presentation. Here. Writing out all these headers. And then we have a way of writing samples here. So this we call write samples, and it will automatically convert it to the right bytes depending on the number of channels and the byte size. So that's what we'll actually be using next. Okay, so now we'll create, well, it's already created, so we'll look at this one. We will create the next one, the realm, but this is going to be the ByteBeat package. So we can utilize riff and wave to create a ByteBeat package. And this ByteBeat package will basically export a single function, ByteBeat, that takes the number of seconds to generate the audio, the sample rate of the audio to generate, and a ByteBeat function, like that little string that's based on t, takes an int and returns an int, and you can do whatever operations you want. This t is going to iterate from 0 to whatever, depending on the seconds and sample rate, and you're going to return something that makes it generate audio. And you can see that this returns a string. So a lot of the things in the smart contract world of Gno, once you get into the realms, deal with strings. So the render function returns a string, and a lot of other functions return strings because it's right now more portable to deal in strings. You can return errors through here, but since we're returning a string, we're actually going to return the base 64 encoded wave file. So once we generate the wave file, we'll encode it base 64 and then return that as a string. Let's go ahead and take a look. So I have here in this audio folder the ByteBeat Gno. So it has the ByteBeat function, seconds, sample rate, ByteBeat function. We create a new buffer, we create a writer from that, We have the samples, we have the channels, and bits per second. So we're going to just do one channel, 16 bits per second, based on whatever sample rate we have. And we create a new writer from our wave writer, which uses the riff writer that I just wrote. And then we'll create some samples. And each sample is just going to be the value of our evaluated ByteBeat function that is fed in. And we write those samples to the writer, flush them, and then get the base64 encoding. That's it. Very, very simple. And we can actually test this. So we're going to have a simple test that actually generates a ByteBeat. And if there's an error, we'll have an error. And then we can print out the data and use that and actually play some music from it. So let's go to the ByteBeat tests. And there's already this complicated string in here. And this is some ByteBeat that was actually in a collection that I found on this website. So we go here, you can see there's a collection of a lot of different ByteBeats. Some of them will work, some of them won't. It depends on whether they use logic. Greater than, just less than signs are not supported right now. So those won't work, but a lot of these other ones will. So we'll generate 10 seconds of audio. Actually, that's a lot. Let's do 5 seconds just for now. And then we'll print it out. So one little thing is that right here we have to change these V1s, since these are actually, as we're testing, we're not using the V1s. I'll talk more about that in a minute. So now we can test, and we'll just go run test, convert base64, decode the base64 into ByteBeat, and then we'll play this file. Turn up the audio. Great, so it is generating ByteBeat audio. So test is working, and that's great. We can have these V1s back. We'll need them later. And we'll go back to our presentation here. Okay, so now that we have a package for riff, a package for wave, and a ByteBeat package, let's create a ByteBeat realm. So the realm is actually what the smart contract is, and it will have a web interface also. And we'll use the web interface to actually show a way to play the audio. So we'll have a little play button to play the audio. And we can also, I'll add in this comment system. We'll get to that in a little bit. So right now, let's just make a basic version of the ByteBeat realm. So we're going to go into, instead of P demo, we're going to go to Gno.land R. R is for realm. And we're going to go to demo. And I already made a ByteBeat folder. So we'll make a new file here, bytebeat.gno. So this is going to be a ByteBeat realm. Close these other ones. And it's going to start just like a regular packet, like a Go package. And you'll see a little later on the special things for realms, but right now it'll look a lot like everything else. So, I should mention that when you do the imports of a package or a realm, we're going to use the name of what it's imported as. So this is in Gno.land P demo. This has got to be the same thing as what you add to the smart contract system. And when you upload to a smart contract, it's immutable. So once we add V1, it's always V1. You can't add another V1 or a different V1. So I use V1 here, so if we do change it, we can change it to V2 and upload a different contract, essentially, a different program based on the same code. So we're going to have a data that will store the data from the ByteBeat generation. And now we're going to get into the first special thing about the Gno realm smart contract. There's an init function just like Go, and just like Go, it's run the first time the program is run. But unlike Go, the program is essentially always running on this distributed system. And once it's running, it never runs the init program ever again. So every time you call things from your program, it will never run this init function again. So we're going to use it to initialize, that's what it's good at, we're going to initialize the number of seconds, 5, and we're going to initialize the data, the base 64 encoded data of the ByteBeat. So we're going to receive bytebeat.bytebeat, and we're using now the ByteBeat package. So we have seconds, we have the sampling rate is 8,000. We'll take a function of t and return int, and here is where we can actually write whatever you want basically. So operations on t, pretty much any operation is allowed. So we can do like a bit shift, we can do an exponential of t, another bit shift, we can do a modulo and multiply by more bit shifting and more logic and more exponential and more bit shifting, more logic, and this could go on forever. You could just keep going and going. There's a whole compendium of these types of strings that you can find on the internet, and they'll work here, or you can just play around with the numbers and make your own. So now after our init function, after we upload our smart contract, it's going to figure out the data to store here and store that forever. Now, how do we actually get it? There's this other thing that's special about our realm, is the render function. The render function is called every time we go to Gno.land, the web interface, and this is a read-only way to basically interact with the contract. And you can use it kind of as a way to look at the state very easily. In our case, the state is a ByteBeat sound, and we want to show the ByteBeat sound as HTML. And we can do that by writing Markdown. So we'll have some Markdown here, and it'll be my ByteBeats. And we'll add some controls for looking at audio. So I'm going to look at my notes here. So we have audio controls equals controls. This is just HTML for displaying some audio, a WAV file in particular. And we have the source. So this is where we'll use our base 64 audio generated. So we're going to have data, audio, WAV, and then base 64. And then we'll add in our data. And then we'll add in the stop. And then we'll return the markdown. And once we return the markdown, the Gno.land interface will actually use the markdown and generate the HTML. So that's it. This is our realm. It's a very small realm, but it's unique. It will be the only one that has ByteBeat audio, I think. And that's it. So we have our packages, we have our realms, and now let's testnet and upload them into a smart contract to actually interact with. So spinning up a testnet is basically to aid our local development. In the future, you'll be able to upload your smart contract to the main net with actual tokens, but right now we have our Genesis block with our tokens allocated for our keys, and we can use those directly on our local machine to actually use the whole system at once. And I've packaged them into the make file, so if we just run make run, you'll see it first does a kill on whatever is already running, and then it runs this thing that we built, Gno.land. So Gno.land is the distributed server running in the background that's handling all of the blockchain interactions. It will also run Gno web in the background, and this is a local interface to Gno.land. So if we go look it up here, this is Gno.land, and there's already some smart contracts here, so like one that lists some users. So there's some user information. These are built into the Gno.land system as is, but we'll be able to basically make add our own in here with our own source code and our own way to interact. So to do that, we're going to use the keys that we generated a while back. And what we have to do is essentially add our packages and then add our realm that uses those packages. So it's a multi-step process. So the first thing we're going to add is that first package that we created in the very beginning here. So that riff package. So we're going to use no key, make transaction, add package. And we'll give it a couple of arguments. So the first argument is the package path. This is what we want to call the path within the Gno.land environment. So within the Gno.land blockchain smart contract system, this package will be forever referred to as this. So anyone can import this once it's uploaded to the system. The package directory is another path, but this is a local path. So this is the path to the files on your computer. No one else will see this. Once it's uploaded, it's always referred to as this. And then the next three arguments are for gas fees that are related to the processing of packages or realms. And these are somewhat arbitrary at this point. They will have real meaning soon. That's being worked out. But right now we've given our key a lot of gnotes, the token for doing gas fees. So we should be able to pay it just fine. And we're going to broadcast this onto the dev chain at this port. And finally is your key. So if we copy all of this over, and then at the very end, I'm going to submit it as your key. Your key is the one that I made. And I enter my password. And after a little bit, we see an OK, gas wanted, gas used. So we successfully have uploaded the first package from this system onto the blockchain, onto a local blockchain. And this can be made a little bit faster because we're going to have to do this for every single one. And, oh yeah, before I do that, quick note, if we do make another version of Riff or any of the packages or any of the realms, we can just simply add v2 here instead of v1 or v whatever, and then import v2. That way, even if we change it locally, it won't be changed on Gno.land until we do another transaction to add that package. So another trick I like to making this, just for development to make it easier, is to use this flag insecure password standard equals true. And then you can pass your password from a file. So I can put a password into a file password and then cat that into the Gno key. So for example, I have a very stupid password and I can cat that password into, I'll get that, into this command if I use this extra argument, insecure password standard in equals true. Now, it's going to automatically add my password, but it's going to error. And the reason it errors is because the package already exists. So like I just said, we can only have one package named Gno.land pdemo audio riff v1. But if we wanted to make a v2, I didn't change anything on the actual file, but I'm going to change the name of it to v2 and submit it. And when we do that, it will actually be able to submit. And now there's a v2 version of the riff package. So if we go to the make file, I automated a lot of this. So there's a make push command. And in particular for this ByteBeat, we have to have a lot of packages. So there's the riff package, and then it's going to upload the wave package, and then the ByteBeat package, and then the ByteBeat realm. So we'll go ahead and start with key equals your key, and I'll do make push. So the riff package is going to fail because we've already uploaded it. That failed. But the rest of them should succeed. So this is uploading the wave package, okay, gas wanted, gas used. Uploading the ByteBeat package, okay, gas wanted, gas used. If you enter a situation where you get an error from not using enough gas, you could just increase the gas wanted. And there we go, okay, gas wanted, gas used. So we've actually uploaded the realm as well. So you can see for the realm, it's exactly the same. R demo, so R is for realm, except the package directory, the local package is different. So you can treat them basically the same. Just remember that realms are the only ones that actually have state. Okay, so now that we have all of our packages on and all of our the realm that we made is on, we can go look at it locally. So this is the address that we have. So we uploaded it as Gno.land/r/demo/bytebeat/v1. So that means it's available locally at this address. And here it is, my ByteBeat. And it automatically starts playing. So let's do that again. That's a little funny. It's a little short. Let's make a longer one. So let's make it 10 seconds long. So to do that, we'll go back to the ByteBeat realm. And this will be, all we're going to change here is 10 seconds. And then maybe actually let's just change some of these things. Why not? Okay. And then we're going to upload it again. So I'm going to just copy this from the make file. And one thing I have to change is that this is going to be another version. So this is v2. The code is in the same place, but we're changing it on the Gno.land server. If we wiped the Gno.land server, we could add v1. But on this testnet, there's already a v1. So we're uploading v2. And now if we go to v2, we have a 10-second version of the ByteBeat. We can play that. That's pretty cool. So this is audio that's generated on the smart contract. So we can see the smart contract. We just go to source here, click that, and this is the source code, and here's the source. This is what's happening on our smart contract. And this page is what's getting rendered by the render function. So there's a lot of extra stuff, but what we've actually rendered, so realm render, is here is our source. This is the markdown that we generated from our render function, rendered into the Gno.land web interface for the smart contract. So let's actually use something from the smart contract that we used the init function a little bit in the data, which is persistent. But let's actually use a little bit more. Let's make a database of comments. So we'll have people interact with the smart contract through comments. So we'll make a comment interface. Let's do type comment, and we'll have a user and a message. And we'll have the data, and then we'll also have comments, which is an array of comments. So here to actually interact with the smart contract, so the render is a way to interact, but only read only. If we want to change something in the smart contract, we can by creating an exported function. So I'm capitalizing this function, add comment, and it's capitalized so it will be exported so that it can be used as a transaction. And we're going to basically add a comment. Comments equals append comments, and then user, I'll get to that, and then the message is the message. And then we'll return OK. So OK is only returned to the user that makes a transaction. So if we had an error, we could return something else. So say if, we can use strings and say if the message is blank, return error, no blank. And then we'll need to import strings so we can go automatically. So what is the user? This is where we can use another one of the features of the standard library of the smart contracts. So to get the standard library, we're going to make another import. This one is for std. This is standing for the standard library of Gno.land, Gno smart contract system, and gives us access to special APIs specific to smart contracts. So one of the things that happens is that for running this function, we're going to have to make a transaction on the chain. And the transaction will be tied to a key. And we can get the caller that makes a transaction. We can get the public key that makes a transaction, because there will always be one. So the caller is going to be std.getOrgCaller. This will get the original caller. And you can do all sorts of other things. I'm doing the most simple thing right now. It's just getting the caller, and we're going to use that string of the caller as the name of the user. Very, very simple. And this is guaranteed to, every time someone adds something, it will add permanently to this list of comments. And maybe we should add a thing to remove comments, but for now, it'll constantly adding comments and they'll be there forever. This is like permanent storage here. It's like a database for free. There's more database. There's an AVL tree that you can use for an actual database, but right now, very, very simple. And then let's add something to the markdown that lists out the comments. So we'll have comments here, and we'll go for every comment we have, we'll output some comments. So I'm actually going to need format.sprint.f, but this is where we run up to things that are not implemented in Gno exactly the same. So format doesn't exist. Format was ported, and we can use part of it, but the whole thing is not ported because it uses reflection, and currently Gno doesn't have reflection. So we're going to use another version that's been made for Gno called uformat. I believe that's the right path. So we can actually go see it here. If we go to P, there's a bunch of helper functions here. P, demo, uformat here. So this provides a utility for formatting strings similar to format, but only a subset because the only subset is supported. So we call it the micro format. So as we're going, we're kind of using that plane while we're building it. So some things have not been ported completely, and we have these Gno.land specific Gno packages to fill in the gap. So we're going to use uformat here. So we'll do uformat, and then now we have sprintf that we can use. So we'll go the comments, and then the user, something like that. So we have ith comment, comment.message, comment.user. So it will display some comments. And let's only if the comments, if we have comments, let's display comments. 0. Oh, I don't know. I put output. I meant markdown. Okay. So now we have some new Gno code for our realm. And now we can add another realm. This will be v3. Because we cannot add, v2 is already taken. Oh, 10 seconds of audio takes a little bit to do. So there we go. We've uploaded it. And now we can call it. But before I call it, before I get right there, let's go check it out. So if we go to v3 here, here's our ByteBeat, and there's no comments. Like before, I hid them, so you won't see them until we add one. So let's add one. So to add one, we're going to use Gno key again, and we're going to do the function this time, make tx call. And call lets you call any exported function. So we have our package path, and it's going to be v3 this time, so this is the third version that we've made. And we're going to use the function add comment here with args specified here. So the function is add comment, and args, we're just say like hello world. And if you have more than one argument, you can have another -- args with the other arguments. And then gas fees, gas wanted, broadcasts to the dev chain, remote ports, and then your key. So copy all of this, but we can add a comment now, v1, and we'll do hello world, enter your password, z, or whatever your password is. And now we go here, we should have a little comment. And this is going to be the public address of my key. And if you have a different user, so I added another user to my Genesis as my key, which is a different a different key, so a different address. I'll just say hi again. Oops. No exclamation points. And then password. So that's calling another transaction. So there will actually be another comment on here. And we still have some of our ByteBeat that we can play on here. So using these exported functions, you can really easily add interactions, and you just interact using the make transaction call with your key. So yeah, that's it. You can use this knowledge to basically create all sorts of ByteBeat realms right now. So all you will do is change the data equals ByteBeat in that realm. So if we go up here, we have this data ByteBeat, and each realm has sources associated with it. So if you generate ByteBeat, they don't necessarily see the ByteBeat that you're hearing, but if you click source and go here, you can see, oh, there's the ByteBeat that I used to generate that. And if you create your own V1, V2, V3, or whatever, anyone can look at the source and then use that source to generate their own realm that's doing something similar, or forking it or changing it. It's all open source. It's all transparent. So Gno and Gno.land are more than anything that I've talked about here. You can explore with tons of examples right on the repository. So if we go to the repository at Gno.lang/Gno on GitHub, in Gno.land, in the demo, there's a bunch of packages that are very useful that you can use. So there's the micro format here, which is porting the format. But there's also Rand, there's Merkle trees, there's GRC, there's blog, there's banking for tokens, there's the AVL tree for a dictionary. There's a ton of stuff that's very useful for realms. And if we look at realms, you can see kind of how they're being used. So we have like foo721, which is GRC 721 implementation, so you can do some NFT stuff here. It shows exactly how to do it. There's a key store, there's the boards that we saw, there's a microblog, there's many different things to explore here. And there's like art things. Anything that you could think of, you can pretty much do. So if you ever thought about a Web3 application, Gno makes the barrier much smaller to start writing it because you usually already know Go. And some up-to-date information on getting started is here too. This is on the README in the repo, and it'll stay up to date versus this presentation, which might go out of date as the months go on. Check out the awesome Gno as well. This has a lot of great resources and a lot of cool things that people are building with Gno. And check out the other talks and definitely join the Discord. That's the best place to ask questions. So if you have any questions about this talk, things I've covered, or you want to know more, or you made something really cool you want to share it on the Discord and tag me and I'll see it. And that's it. Thanks all for listening, following along, and a big thanks to the amazing Gno team, Jay, Manfred, Morgan, Milosh, Antonio, Michelle, Johnny, Vala. Everyone is just so amazing, and it's really cool to see how this language is growing. Thanks a lot.